Hey everyone, so today we are going to talk about problem number 56 in quantum mechanics, which basically talks about Hamiltonian operator, momentum operator and parity operators and their relation. So it says that consider the one-dimensional motion of three particles and three operators, right? One operator is Hamiltonian, another is momentum operator and then parity operator. And which of the following is commuting, right? So it is saying that free particle in 1D, right? Let us take this solution. So what is the free particle in one dimension? If it is a free particle, then no force is acting on it. Then it means that potential is zero. If F is zero, it means that F is nothing but the gradient of V, right? Gradient of V is zero, it means that V is also zero. So potential is zero, right? If you take the potential as potential energy, so force is potential energy, right? Field is potential. So this is zero. It means that Hamiltonian is nothing but the kinetic energy only. That is momentum square by 2 for a free particle. For a free particle, F is 0, this is there. So now it says that first one, which is, remember that parity operator commutes with operators of even parity, right? So parity operator commutes with operators of even parity. Operators of even parity. So this result you must always remember, so that if any problem related to it is asked, you can answer it. So let us take the first bracket, which says that HP square. Now HP square is what? It is P square by 2m P square. Now it is simple. This is simply vanishing, right? Both are commuting, momentum is there. The second one is H and parity. Now as I said, H is nothing but P square by 2m, and this is parity operator. Now P square commutes with P as it is of even parity. Even parity. So it means that this is going to be 0. The third one, which says that PP square, which is very similar to this, the second one, which is HP square, right? So it is P square is against 0 by same reasoning, that the parity operator commutes with the operators with even parity. But fourth one, which is related to P, and P is not 0. They are not commuting because P, the momentum is odd parity operator. This result we have already discussed. Momentum is an odd parity operator. Right? So this is a very good problem, which gives you some idea about what happens, about what is even parity, what is odd parity operators, and how their commutator behaves, right? Which is extremely useful in most of the competitive problems, right? Master's level and obviously and also at the graduation level, right? So hope you will find it useful. Now let us take this problem number 57, which says the initial wave function of a particle in a harmonic oscillator potential can be written as psi at 0 equals to a 3 psi 0 x plus 4 psi 1 x, right? Where a is a normalization constant and psi 0 and psi 1 are the ground and first excited state wave function of the harmonic oscillator wave function, harmonic oscillator, right? Then what is the value of mod psi x naught square, right? So it is simple. Mod psi x square is nothing but psi star psi. Solution. So mod psi x naught square is nothing but psi star psi, right? But remember that before finding psi star psi, you need to first calculate A, right? So what is A? You first normalize it. Remember that this is a harmonic oscillator, so the potential varies from minus infinity to infinity, right? Psi star psi dx. It's one dimension. So it says that A star A, which is mod A square, and this gives you nothing but minus infinity to infinity 9 psi naught square, which is psi naught star psi naught dx, plus 16 psi 1 square dx, right? Which is equals to 1, giving you mod A square is nothing but, there they are normalized. Now this will give you 9 mod psi naught square dx plus 16 mod psi 1 square dx equals to 1, right? So this is nothing but normalized as 1 and this is 1. So giving you A mod A square is nothing but 9 plus 16, which is 25, equals to 1. It means that A is nothing but 1 by 5, right? So normalized wave function will be, it is simply equals to, normalized wave function will be, it will be psi x comma 0, which is equals to 1 by 5, 3 psi naught x, this is excited state, right, wave function, right, plus 4 psi 1. Now mod psi naught square or psi x 0 whole square is nothing but 1 by 25, right, equals to mod psi star psi, which is nothing but 1 by 25. Now remember that 3 psi naught square x, sorry, psi naught star plus 4 psi 1 star multiplied by 3 psi 1 plus 4, sorry, psi naught plus 4 psi 1, right? Now these wave functions are, sorry, they are not orthonormal. The function of a harmonic oscillator is not orthonormal, right? So this 1 by 25 gives you 3 multiplied by 3, which is 9 psi naught square, plus 3 multiplied by 4 is nothing but 12, right? And psi naught star psi 1 plus 4 multiplied by 3, which is 12 psi 1 star psi naught, right, plus 16 mod psi 1 square, right? Now if you look at it very carefully, what exactly it gives you is nothing but, it gives you 1 by 25 9 mod psi naught square plus 16 mod psi 1 square plus 12 plus 12, 12 2 times, basically it is nothing but mod psi 1 psi 2 multiplied by 2. So it is 24 mod psi naught mod psi 1. So this is what you are getting H, they are not orthonormal. So this is what you have as the mod of the square of the wave function, which is a combination of wave function in the down state and the first excited state. A very significant problem, an easy one, but significant one because it is usually asked in the exam. Problem number 58, which says that the Hamiltonian operator for a two-state system is given by H cap equals to A and 2 multiplied by state 1 1, outer product 3 1 2 and minus 2 1 1 as the state, right? Where A is a number having the dimension of energy, so find the eigenvalues and eigenvectors for the operator H. Right? So let us write, you can see that this is an operator which is basically the matrix form. So just write it in the matrix form. Right? So this is the one, this is 1 1, this is A2. So take A out. And then this is will be 2 1 1. Right? And this is 1 2, this is minus 3, this is 2 1, this is minus 1 and this is 0. Right? So it is asked that what is its eigenvalue, right? So its eigenvalues are can be found at H psi equals to lambda psi using this type of relation. H psi equals to lambda psi, right? So let us use this relation, H psi equals to lambda psi. So H, which is this, it gives you 2 minus 3 minus 1 0 minus lambda psi equals to 0. So this is this H minus lambda to psi equals to 0. So lambda into I. Where I is a matrix, lambda is a scalar, right? So this, now this is there, you just try to solve it, it gives you 2 minus lambda into minus lambda minus of 3 minus 1 is 3, right? 3 equals to 0, right? Now just simplify it. So it is minus lambda plus lambda square. It gives you minus lambda plus lambda square minus 3 equals to 0. Right? Lambda square minus lambda plus 3 equals to 0. Minus 3 equals to 0. Right? So let us solve it. So lambda will be minus b. Minus of b, where what is it? B is minus 1. So minus b is 1 plus minus root b square, which is minus 1 square, minus 4a into c. 4, a is 1 and c is minus 3. Right? Divided by 2 into a. So it gives you 1 plus minus. How much? Divided by 2. So just let's look it again. 2, 1, 2 and 2, 1. 0. So 2 minus lambda and then 0 minus lambda minus 3 minus 1. 2 minus lambda, then minus of minus 3 minus 1. 2 minus lambda plus lambda square. Sorry, here it is minus 2 lambda. Right? So it will be how much? Minus will b will be 2 and this will be 2 square, which is 4. right? So 4 plus this will be 16. Right? Divided by 2a. So 2 plus minus 16 is 2 plus minus 4 divided by 2. Right? So 1 will be 2 plus 4 divided by 2. 6 divided by 2 is 3, and 2 minus 4 is minus 2 divided by 2 is minus 4. These are the two roots, 3 minus 1, right? Now let us go to their eigenvalues, right? Sorry, eigenvectors. So eigenvector corresponding to 2 and minus 1. Let us find out for lambda equals to 3a. H psi equals to lambda psi. So it gives you 2a minus 3a minus a and 0 minus of lambda, right? Psi 1, psi 2 means lambda times which is 3a psi 1, psi 2. Let's simplify it, gives you 2a minus 3a minus 3a minus a minus 3a psi 1, psi 2 is 0. Right? So it gives you minus a psi 1 minus 3a psi 2 and minus a psi 1 minus 3a psi 2 equals to 0. So it means that minus of psi 1 equals to 3 of psi 2. So if psi 2 is 1, psi 1 is minus 3, right? If psi 2 is 1. So the first matrix will be for lambda equals to 3a, psi 1, psi is minus of 3 and 1, and its normalization will be obviously 1 by root 10, right? Minus of 3 psi 1 and 1 psi 2. This is there. Sorry, minus of 3 and 1, right? Multiplied by 1 and state 2. Right, because it's a combination of 1 and 2. Right? Still psi 1 is nothing but state 1, psi 2 is state 2. Right? Now let us go to this one, that lambda equals to 2a, minus a. For lambda equals to minus a, here you will have minus a, which simplifies it as 2a minus 2a plus a minus 3a minus a and plus a, right? Psi 1, psi 2, which is 1 and 2 obviously. So just multiply 3a psi 1 minus 3a psi 2 is 0 minus a psi 1 plus a psi 2 is 0. It means that psi 1 is equals to psi 2 in this case, right? The wave function will be in this case nothing but 1 and and normalized by 1 by root 2 psi. So psi is nothing but 1 by root 2, 1 and 2. So these are the two eigenvectors corresponding to the eigenvalues 3a and a, right? This is for 3a and this is for the a, for lambda equals to minus a, right? A very simple and straightforward matrix problem in the quantum mechanics, right? Hope you will find. Now let us discuss this problem 59, which says suppose a particle is in state P, which is equals to 1 by root 20, 3, 1 minus 2i into 2 plus root 7, 3. 1, 2 and 3 are the orthonormal bases. And then for an observable B, which is capital B, which is equals to A11 plus B33, the probability of measuring small b in such a state is what? Right? So you have to calculate the probability, remember that. So remember that this is an observable and this is your state. To measuring an observable, probability of measuring an observable. Observable B, which is basically part of capital B, in P is in state P is nothing but the probability P. If you write probability, equals to nothing but 3p whole square. Right? You know that this is the inner product, and whatever inner product you get, you simply square, which is basically nothing but the amplitude of that wave function, right? And which this observable belongs to, right? This belongs to state 3, so it will be simply. So what is 3 to 3? 3p is nothing but root 7, right? Root 7 whole square is nothing but 7, right? So root 7 by 20. So it is nothing but root 7 by 20. So 7 by 20. So this is your probability, right? This is a simple problem, but a very important, significant problem. That you always need to understand that observable belongs to which state, and then correspondingly you can calculate the probability in that particular state, right? By taking in a product with the state, with the observable belongs to the actual state, right? And just to square it, it will give you the CI square, right, which gives you the probability, right? So here this problem number 59 is there. Very simple but very significant problem. Let us take this problem number 16, which says that in a system described by the 3 orthonormal bases 1, 2 and 3, the operated form of an observable is a cap equals to 7, 1, 1 plus 9, 2, 2 and minus 5, 3, 3 state. So what is the possible measurable value of observable A, right? So to solve it, remember that what is the operator corresponding to observable? So it is given by E cap, which is 7 as 1, 1, 9 as 2, 2 and then 3, 3. It's just a 3 cross 3 matrix, and so with other elements 0, right? 7 and minus 5. So what are the observable values it will have?
So it is, you can calculate A psi equals to lambda psi and find the lambda, which is nothing but the expectation value of operator, which will be a measurable value, which will give you a measurable value. So as it is diagonal, so 7 minus lambda 0 0 giving you 7 minus lambda, 9 minus lambda, minus 5 minus lambda, 0. Our lambda equals to 7, lambda equals to 9, and lambda equals to minus 5. So these are the values which are measurable values. Basically, these are nothing but diagonal elements of the matrix also. Right? So measurable value of the operator, the observable A corresponding to operator E cap is 7, 9 and minus 5. Very simple and significant problem. Basically, you have to understand that what is the measurable value of an observable corresponding to a given operator. So once you understand it, you can easily tackle this problem, right? And this type of problems are usually asked in the GATE exam. They look simple, but not everybody is able to tackle it, right? Now let us go to the problem 57 again and discuss one important thing, which is related to like problem 57 says, so wave function was given, if you recall, psi x0 as 1 upon 5 we calculated, and 3 psi naught plus 4 psi 1, right? This is something this was given, and this will be calculated. Now it is asked that what is psi xt, right? So psi xt can be calculated as, first we are calculating psi xt. So psi xt is what? Psi x naught e to the power minus I e t divided by h hat, right? So psi x comma 0, which is equals to 1 by 5, 3 psi naught e to the power minus I e naught t divided by h hat plus 4 psi 1 e to the power minus I e1 t divided by h hat, right? But remember that e1 minus e naught is nothing but h hat omega for an oscillator. It is 3 by 2 h hat omega, it is half h hat omega, right? So this is the difference. So when we take the psi xt square, it will give you cross terms like 1 by 25, 9 psi naught square, plus 16 psi 1 square, plus 12 psi naught star psi 1, right? Because you are taking psi star and psi 1. You can keep it here 1 by 25 psi naught e to the power minus I e naught t divided by h hat plus psi 1 complex conjugate becomes positive I e1 t divided by h hat, and then psi naught e to the power minus I e1 t divided by h hat plus psi 1 to the power minus I, sorry here e naught e1 t divided by h hat. So this is there. When you take this multiplication, it gives you this complex term cancel out, psi 1 star psi 1 complex term cancels out, but not in the case here. It gives you I e naught minus e1 into t divided by h hat. This is minus I omega, right? And this plus 12 psi1 star psi1 e to the power I, right, this E1 minus E0 into T divided by H. So what does it gives you? It gives you minus of h cut omega and minus of omega t, as that you will put h cut omega as h cancels out, giving you omega t. This gives you 1 by 2 9 psi naught square plus 16 psi 1 square plus 12 mod psi naught mod psi 1, and then take it as common, right? It gives you what? E to the power minus I omega t plus e to the power I omega t, right? This is e to the power I omega t, this is minus e to the power minus I omega t. Now what it is? If you divide by 2 and multiply by 2, it gives you cos omega t. So it gives you 24 psi naught psi 1 cos omega t, right, along with these terms, 1 by 25 9 psi naught square plus 16 psi 1 square, right? So this problem at psi xt is something like this. Again, a simple straightforward problem, right, but very significant. Hope you will be able to solve it if a similar type of problems comes anywhere in the exam, right? This is all we have for today's lecture. We discussed problem number 56 to 60, and all the problems were very significant related to various exams, right? Thank you.